This remarkable plant, the winged bean, presents us with a singular treasure, one source yielding 5 entirely distinct food types. Consider its seeds, its leaves, its flowers, its tubers, and its pods. Each and every part is not only edible, but exceptionally rich in protein. The seeds in particular boast a protein content exceeding that of soybeans. Back in 1975, a leading scientific body in America recognized this plant as the supermarket on a stalk, suggesting its potential to eradicate global hunger. Yet its widespread recognition subsequently faded. What became of this extraordinary winged bean? Now, allow me to transport you to the elevated terrains of Papua New Guinea. Envision precipitous mountain terraces meticulously sculpted into volcanic soil, a testament to over 2,000 years of agrarian cultivation by local farmers. Ascending their bamboo trellises, you will discover a climbing vine adorned with the most peculiar pods imaginable. 4 delicate frilly wings, reminiscent of gossamer green ribbons, gracefully extend along the length of each pod. The blossoms are a pale, almost ethereal blue, possessing a luminous quality. Its leaves are broad and abundant, and beneath the earth's surface, substantial tubers are quietly developing. This is Psophocarpus tetragonolobus, the winged bean. Its true marvel lies not in a solitary edible component, but in the bounty of its 5 distinct offerings. Let us begin with the seeds. Upon cracking open a mature pod, you will discover small, spherical beans, visually akin to soybeans. These seeds contain between 29 and 39% protein by dry weight, placing them in direct contention with soybeans, which typically offer 35 to 40%. But here's where the intrigue deepens. These seeds also yield 15 to 18% oil, a high-quality edible oil comparable to peanut oil. Thus, you acquire both a protein source and an oil source from a single crop. Now, let's examine the leaves. While most bean varieties primarily provide beans, the leaves of the winged bean are a staple leafy vegetable consumed throughout Southeast Asia. They contain between 10 and 15% protein on a dry weight basis, a striking contrast to spinach, which offers around 3%. You are looking at a leafy green with approximately 5 times the protein content of what many of us consider a nutrient-dense vegetable. Next, we turn to the flowers. Those delicate pale blue blooms that so effectively attract pollinators are entirely edible. Farmers in Myanmar and Thailand frequently incorporate them into salads and stir-fries. These flowers contribute 5 to 7% protein, even the blossoms adding nutritional value to meals. And then there are the immature pods themselves. Before the seeds fully develop, the entire pod is consumed, much like a green bean. Every element, the distinctive wings, the tender flesh, the nascent seeds within, is both edible and nutritious. However, the most astonishing revelation lies beneath the soil. The winged bean produces tubers, thick, starchy roots that bear a resemblance to small potatoes. And here is a statistic that demands your attention. These tubers contain a remarkable 20% protein by dry weight. For comparison, potatoes offer approximately 2% protein and cassava a mere 1%. The winged bean tuber provides 10 to 20 times more protein than the starchy staples that sustain billions of people globally. When you aggregate the nutritional contributions of all 5 parts, you have a singular plant that delivers comprehensive sustenance. It furnishes protein from multiple sources, carbohydrates from the tubers, valuable oil from the seeds, and essential vitamins and minerals from the leaves. A farmer cultivating wing beans is, in essence, cultivating an entire food system supported by a single climbing structure. This is not a recent innovation from a contemporary Silicon Valley food technology enterprise. Indigenous communities in Papua New Guinea, Indonesia, Myanmar, and the Philippines have understood this for centuries, though they may not have published academic papers detailing their findings. Nevertheless, in 1975, a significant publication finally emerged. The National Academy of Sciences in Washington, D.C., released a report destined to be transformative. Its title was straightforward: The Winged Bean, a high-protein crop for the tropics. The conclusions, however, were extraordinary. Esteemed scientists representing the pinnacle of American agricultural research characterized the winged bean as a potential supermarket on a stalk. Consider the context of 1975. The world was still grappling with the repercussions of the oil crisis. Global food prices had escalated dramatically, and malnutrition in tropical developing nations was reaching critical levels. Here was a plant, already cultivated in village gardens across Southeast Asia, possessing the capacity to provide complete nutrition with minimal resource input. This seminal report spurred an influx of research funding, leading universities worldwide to initiate winged bean development programs. A follow-up report in 1981 documented even more remarkable discoveries. Researchers found that winged bean roots engage in a symbiotic relationship with nitrogen-fixing bacteria. These microorganisms extract nitrogen directly from the atmosphere, converting it into a form of fertilizer within the soil. This plant not only nourishes people, but also enriches the soil, thereby improving the land's fertility for subsequent seasons. And this is where modern scientific inquiry becomes critically important. Climate scientists studying crop resilience have observed that winged beans flourish within temperature ranges where soybeans often struggle. Soybeans exhibit a narrow, optimal temperature window for growth. In contrast, winged beans not only tolerate the heat and humidity characteristic of tropical lowlands, but also thrive in highland environments. As climate change progressively elevates global temperatures and exacerbates weather unpredictability, crops like the winged bean gain increasing significance rather than diminishing value. The analysis of its amino acid profile reveals another compelling narrative. When researchers meticulously examined the quality of the protein, they discovered that winged bean seeds are particularly rich in lysine. This particular amino acid is frequently deficient in plant-based diets. By combining the seeds with the leaves, one achieves a nearly complete profile of essential amino acids without the necessity of consuming animal products. Traditional farmers were not haphazardly consuming this plant. They were employing sophisticated nutritional science, integrating various components of the plant to achieve comprehensive dietary balance. Modern laboratory analyses have served to validate the profound knowledge that indigenous communities had preserved across generations. Consequently, the scientific foundation was robust, the nutritional value exceptional, international researchers were enthusiastic, and funding was abundant. The supermarket on a stalk was poised for its global debut. Then, it seemingly vanished. The events transpiring between 1985 and the present day are not a tale of clandestine conspiracies, but rather a narrative of systemic forces. It illustrates how global priorities determine which crops receive attention and which are relegated to obscurity. To comprehend the systematic sidelining of the winged bean, one must first understand the phenomenon of the Green Revolution. Beginning in the 1960s and accelerating through the 1980s, international development organizations fundamentally reshaped global agriculture. Their primary objective was straightforward: to increase crop yields, feed a growing population, and avert widespread famine. The chosen methodology was monoculture. This involved cultivating high-yield varieties of wheat, rice, and maize across vast expanses of single-crop fields, supplemented by extensive applications of synthetic fertilizers and pesticides. This strategy proved effective, leading to substantial increases in agricultural output and successfully averting numerous famines. However, an unintended consequence emerged: a dramatic decline in crop diversity. The Food and Agriculture Organization of the United Nations has documented that in certain tropical regions, indigenous crop diversity experienced a 75% reduction within a single generation. Farmers who previously cultivated a multitude of food plants transitioned to growing one or two cash crops, leading to the abandonment of traditional varieties and the erosion of local agricultural knowledge. The winged bean became one of thousands of casualties of this shift. Yet, another critical factor warrants examination. The ascendance of the soybean to its status as the world's predominant protein crop was not a matter of chance. Its dominance was engineered through the deliberate construction of entire systems around it. Consider what the soybean possesses that the winged bean lacks. Soybean pods mature uniformly across the entire plant, a characteristic that facilitates mechanized harvesting with combines capable of covering hundreds of hectares. In contrast, winged bean pods mature asynchronously over a period of 2 to 3 months, with each pod ripening at a different interval. Harvesting necessitates manual labor, requiring repeated visits to the same plants. Soybeans can be dried and stored for extended periods, and a global infrastructure exists for their processing, including crushing facilities, oil extraction plants, and protein isolation equipment. An industrial capacity valued in billions of dollars, specifically tailored for soy. Winged beans, on the other hand, have a fresh shelf life of only 3 to 5 days without refrigeration, and no comparable processing infrastructure is readily available. Furthermore, government policies played a pivotal role. The United States subsidized soybean production for decades. Trade agreements actively promoted soy exports, and substantial research funding was allocated to soybean improvement initiatives. A farmer in Iowa opting to cultivate soybeans benefited from an entire ecosystem of supportive markets, technology, and policy. Conversely, a farmer in Nigeria choosing to grow winged beans operated largely independently. This is not a narrative of a superior crop being supplanted by an inferior one. Soybeans are genuinely valuable, and the existing infrastructure is efficient. The system functions effectively. However, this story highlights a crucial aspect of how we select our crops. The most advantageous crop does not always prevail. The most industrialized crop often wins. For 40 years, the supermarket on a stalk has continued to grow in village gardens across the tropics, largely unchanged and largely overlooked. It is imperative to grasp the full implications of this situation. The winged bean is not an isolated anomaly. It exemplifies a broader pattern. Agricultural scientists estimate that throughout human history, over 7,000 plant species have been cultivated for food. Today, a mere 3 crops, rice, wheat, and maize, account for over 50% of global caloric intake. 15 crops collectively provide 90% of our food calories. What has become of the remaining 6,985 species? How many other supermarkets on a stalk are currently disappearing unnoticed, while our attention remains fixed on a select few staple commodities? However, this narrative does not conclude in 1985. In a research facility on the outskirts of Bangkok, Thai scientists are actively developing new winged bean varieties. These cultivars are yielding more pods, maturing more uniformly, and exhibiting enhanced resistance to diseases. In Nigeria, researchers are crossbreeding African winged bean lineages with Asian varieties, thereby creating hybrids better adapted to West African environmental conditions. In Malaysia, a dedicated breeding program has successfully developed varieties specifically optimized for their tuber production. Recognizing the profound potential of protein-rich root crops to revolutionize food security, scientists dedicated to orphan crops rarely capture headlines. They do not attract venture capital funding or the attention of Silicon Valley. Nevertheless, they are diligently rebuilding the reservoir of knowledge that was largely abandoned 40 years ago. Concurrently, a resurgence is occurring in farmers' markets throughout Southeast Asia. Winged beans are reappearing with greater frequency, not as a novel curiosity, but as a valued and sought-after vegetable. In the Philippines, Wing bean leaves are gaining popularity among health-conscious urban consumers. In Myanmar, traditional dishes featuring wing bean flowers are being rediscovered by innovative young chefs. The food sovereignty movement has embraced crops like the wing bean as potent symbols. Cultivating indigenous vegetables has become an act of defiance against monocultural agricultural practices, and saving heirloom seeds has transformed into a political statement. The supermarket on a stalk symbolizes not only nutritional sustenance, but also personal and community autonomy. To be perfectly candid, it is unlikely that the wing bean will supplant soybeans on a global scale. The disparity in industrial infrastructure is simply too vast, and the challenges associated with harvesting remain significant, compounded by the absence of large-scale processing technologies. However, this framing of the question is fundamentally flawed. The crucial question revolves around diversity. Our current food system is perilously narrow. Relying on 3 crops for half of our caloric intake presents 3 critical points of vulnerability: a single disease, a singular climatic shift, or a solitary pest outbreak could potentially devastate global food security. We require a broader array of options, not a contraction. The winged bean represents one such option, a vital component in fostering a more resilient food system. The very scientific principles that validated this plant in 1975 can now be harnessed to facilitate its resurgence. Investment in processing technologies can effectively address shelf life limitations. Strategic breeding programs can overcome harvesting challenges, and increased consumer awareness can stimulate market demand. We have known about its efficacy for 50 years. Therefore, let us return to our starting point, Papua New Guinea. Picture those highland terraces, a vine gracefully ascending a bamboo trellis, yielding 5 distinct food sources from a singular root system. These are farmers who never required laboratory validation to confirm what they had already intimately understood. The winged bean was not a race through conspiracy or malicious intent. It was systematically marginalized by systems that prioritize efficiency over resilience, monoculture over diversity, and industrial scale over nutritional density. It was gradually erased by the subtle yet pervasive influence of markets and policies that elevate certain crops while neglecting others. Nevertheless, the plant persists in village gardens from Myanmar to Nigeria, and within research stations where dedicated scientists refuse to abandon their efforts. Its genetic diversity endures despite our collective neglect. The real question is whether we will remember to look for it. Will we commit to investing in the necessary research, constructing the requisite infrastructure, and cultivating the essential markets? Perhaps an even more profound question emerges. What else are we losing in this present moment? What other crops? What other forms of knowledge? What other possibilities are silently fading away while our attention is elsewhere? If this investigation has illuminated your understanding, please share it with others who would benefit from this information. Subscribe if you wish to continue delving into these hidden histories, and leave a comment suggesting which forgotten crop we should investigate next.